Ever wondered how machines predict outcomes based on past data? Welcome to the fascinating world of machine learning. Machine learning is a field of artificial intelligence where systems are trained to learn from data, identify patterns, and make decisions. It's like teaching an old dog new tricks. Only these dogs are computers and the tricks are complex computations. There are two main types of machine learning: supervised and unsupervised. In supervised learning, we teach the machine using data which is well labeled. Unsupervised learning, on the other hand, is a method in which the model is asked to identify patterns in the data on its own. Now, let's introduce our main topic, the naive Bayes algorithm. This algorithm, named after Thomas Bayes, is a classification technique based on Bayes' theorem. It comes with an assumption of independence among predictors. Despite its simplicity and the naive assumption of feature independence, it's a powerful tool, especially for text classification tasks. So, ready to delve deeper into the naive Bayes algorithm? Let's get started. Naive Bayes, a simple yet powerful algorithm, has its roots in Bayes' theorem. But what makes it naive, you may ask? Well, let's dive right into it. To understand naive Bayes, we must first understand Bayes' theorem. In essence, Bayes' theorem is a way of finding a probability when we know certain other probabilities. The theorem updates our initial beliefs after obtaining new data. Hence, it's often associated with the term conditional probability. In the world of machine learning, this theorem is a foundation to many classification algorithms, including naive Bayes. Now, onto the naive part of naive Bayes. This refers to the algorithm's key assumption. The predictors or features in the input data are independent of each other. This means that the algorithm assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature. For example, if we want to predict whether a player will play or not based on weather conditions, the algorithm would consider each weather condition as an independent entity. However, here's the catch. This assumption of independence among predictors is often not true in real-world scenarios. Let's stick with the player and weather example. In reality, weather conditions are not entirely independent of each other. A windy day can often be correlated with a less sunny day. Despite this simplifying assumption, the naive Bayes algorithm works efficiently and is widely used. It's like an artist who paints with broad strokes, yet somehow manages to capture the essence of the subject. This is because the algorithm's performance is not necessarily dependent on this naive assumption being true. It's a testament to the algorithm's robustness that it can perform well even when its assumptions are somewhat violated. Interesting, isn't it, how this naive algorithm can predict so accurately? It's like having your cake and eating it too. The naive Bayes algorithm, despite its simplicity, stands tall among the giants of machine learning algorithms, and that's the beauty of it. Now that we understand the naive Bayes algorithm, let's see it in action. One of the most common applications of the naive Bayes is in the field of text classification. Here, it's used to categorize documents into different classes, making it a powerful tool in natural language processing. Take spam filtering, for instance. Naive Bayes can be used to identify whether an email is spam or not by analyzing the words in the email and their likelihood of appearing in a spam message. The algorithm learns from a data set of known spam and non-spam emails and then applies these learnings to new emails to classify them. In addition to spam filtering, naive Bayes is used in sentiment analysis. This involves determining the sentiment of a piece of text, whether it's positive, negative, or neutral, by calculating the probabilities of different sentiments based on the words in the text. Naive Bayes can provide valuable insights into customer feedback, social media comments, and more. From spam detection to sentiment analysis, naive Bayes is making our lives easier every day. Let's take a moment to reflect on what we've learned today. The naive Bayes algorithm, a classification technique grounded in Bayes' theorem, makes an assumption of independence among predictors. This assumption, while simplifying, can sometimes be a limitation as real-world data often interrelate. However, the algorithm's efficiency and performance, especially with large data sets, make it a popular choice among machine learning enthusiasts. We've also delved into the various applications of naive Bayes, specifically in text classification tasks. Remember the example of predicting whether players will play based on weather conditions? It's just one of the many practical uses of this algorithm, demonstrating its versatility and efficacy. We also discussed how to improve the performance of a naive Bayes model with emphasis on data pre-processing and feature selection. These steps can help optimize the model's predictions and overall accuracy. No doubt, the naive Bayes algorithm has a lot to offer, so keep exploring and keep learning. Until next time.